Hello, everyone. We are just about to get started, okay? 2 minutes away, and we will get things going. Hey, Jelly. Hey, Mateo. Good to see you. Good to see you, Jelly. Good to see all of you. Hey, Thang. Hello. Okay, everyone. Okay, so let's get things going. Thang is asking a question. Professor, will you be teaching the web development course in the third semester for us? I don't know, Thang. We only know what you're going to be teaching the following semester. So I only know for summer that I'll be teaching the same course again. But for fall, I don't know if you're talking about summer or fall. I'm not, I don't know what the summer term. Yeah, summer term. I won't be teaching web development course. No, I will be teaching this course again during summertime. Okay, so but hey, now you know, so now you can take web development, because I won't be there. So again, it's not going to be the bad Ederson. Okay, I'm glad. Thank that's yeah, but too bad that I won't be. Okay, um but again, you're going to do well in you know the other instructors are great instructors. Not that I'm great, but the other ones are great. No. Okay, so welcome everyone to our evening, to our meeting on our Wednesdays. Okay, so good to see all of you. You may see that I am in a different environment right now. Okay, not the usual one, but hopefully the quality of the voice is coming across okay. I'm at a friend's place. Uh, I have our little one. We have two daughters, and our 9 years old. She is a bit of a handful. She has ADHD and she has ODD. Lots of little letters and lots of acronyms. ODD is, I don't know if anyone has heard of that before, but it's oppositional defiant disorder. And what that means is that her tantrums are not the regular kids tantrum. They are very intense. They are yes, very intense. She throws things. She wants to, you know, to hurt, and it becomes hard to deal with her at times. So I had to ask for a friend's place today to be able to have our meeting, because I didn't want to risk having the meeting there and she throws one of the tantrums at that time. It's not a good way to teach a class if you are always, listen to if there's something going wrong. So it's not good to do that. No, it's not good to have a meeting in general, but again, in class is not good at all. So that's where I am. And I just had one meeting before ours, and everything went fine. The internet here is good, so we are all fine. We are all good. And yeah, so let's get our week number 10 started and moving here. So to get us started, as you may have seen, all midterms have been graded. We had a little bit of a mix of everything there. I want to tell you, just want to make it clear that the last test, the last one in the last week, we're gonna do a little bit, we're gonna have some additional prep time for that. That test, don't think that because it's the last one, it's more difficult than the midterm. It's not. So it's gonna be, I would say, it's gonna be a simpler test. And again, if by any chance you are considering to drop the course because of what you may have gotten in your midterm, think again, because I will tell you this: the last test will not be, I would say, as involving as the midterm. Okay, so you can count on that. Okay, okie dokie. With that said, let's dive into our week number 10, which means going through the content of week number 9, going through some demonstration there. So let me know if you have gone through the content of week number 9. Hopefully you had a chance to do that. What is the topic? What is the topic of week number 9? Anyone enlighten me there in the chat? There is inheritance there, Mateo, but there is more than inheritance. Okay, so inheritance is an element. Yes, it's going to be polymorphism. Yes, Aman. So it's about polymorphism. It's about abstract classes. It's about interfaces as well. Okay, so it goes. Let's put it this way. It steps up the topic of inheritance. It's inheritance, but now with abstract classes, with interfaces as well, with the definition of polymorphism. Actually, it's a good word that you have brought there. Let me go here to the content a little bit. So let's go to week number 9. So polymorphism and interfaces. Okay, so I would highly recommend that you go through the content of the extra content as well. Why I'm saying that? Because once again, you're going to see my explanation that I have done in class to students of 1 year ago. Polymorphism, interfaces, they didn't change within the year. Okay, so this is as valid as it was a year ago as it is now. Okay, so go through them, because the demonstration that I'll be performing today will be focusing on abstract classes. We will not have a chance to look closely, at least not today, into interfaces. Okay, and interfaces is also very important. It's going to be part of your last assignment. It might be part of the test as well. So it's important that you look at interfaces. I'm going to try to do some demonstration of interface as we go through the content of next week. I'm not sure if I will be able to do that or not, but again, it's your job to go through this content here. And if you went through the content, went through the videos here, went through the exercises, all exercises I'm providing answers as well to them, and you still don't get it, what interface is, reach out to me. But today, my focus will be on abstract classes, which I'll be performing a demonstration about that, okay? But again, go through this content. This content is very, it's what I cover during class time, okay? So with that said, there are a few lab assignments for week number 9. Actually, 2 exercises here, 2 major exercises: polymorphism shapes and 3D shapes. For both of them, I have provided the corresponding solution file. It's a zip file, okay? I'm not going to go through the demonstration of those. I'm going to choose, I have chosen the demonstration of one exercise under the extra content, which you can see here, polymorphism interface. This is the PowerPoint version. This is the PDF version of the PowerPoint that I demonstrate here on the different parts. Then we have this set of exercises. And by the end of the day today, I'll also be opening up the solutions for all 4 exercises that can be found here in this PDF. Okay, let's have a look at that. So those exercises, they are about abstract classes and interface as well. Abstract classes and interface, they are kind of similar, but not the same thing. They are relatively, again, similar, but not the same. Okay. So with that in mind, let's just talk a little bit about what is polymorphism. When you hear this word, which may sound strange and foreign, and you may not have any clues about what this might be. What do we understand about this word? I mean, anyone understands anything about this word polymorphism? And it doesn't need to be coding based. It might be anything else that comes to mind. What comes to mind when you hear the word polymorphism? Anyone? It's a combination of, go ahead, sorry.
I was going to say transforming something into something else.
Good one. I like that. I like the transformation part. Anybody else? Let's see here. Mateo? I think it's writing the same block several times, but allowing it to be slightly different arguments. Interesting thing that you defined there. Mateo, I like that too. Aman said many objects. Poly, yes, many. Poly means many. Okay. Block of code. Okay, so everybody that mentioned something has some, it's towards the same direction here. But let's break it down. Let's break it down. This word polymorphism. Poly, many. Morph, form. Many forms. Many. And by the way, I don't know if internet is okay, but here and there I'm getting a message that my internet is unstable. So just keep me on check here in case the voice is not coming across properly, okay? I think it's freezing a little bit because I can see myself in the other window as well. Anyway, so polymorphism, poly, many, morphism, forms, many forms. For instance, let me give an example of a polymorphic behavior. When you look at animals, different animals, they make noises, okay? And I'm not gonna worry about exceptions here, okay? I'm talking about a cat, a dog, a horse, okay? I'm talking about those animals there. Froze a bit, yeah. I see that the other group had a little bit of that as well, but let's see. It's frozen. Completely frozen now. I mean, what do you say? Is at least the voice coming? Oh, let me turn off the. I'm gonna turn off the camera. Oops. Can you hear me? Yeah. Okay. Because my other device has just stopped and now it came back, and now I'm gonna share my screen again. Sorry. Okay. So I think it's sharing again. Okay. Okay, perfect. So I'm muted here. No, that's fine. Okay, okay. So again, I'll just keep checking the chats to see how things are. Just put the. Okay, and I no longer see you guys. Let me. longer see. Oh, it's because my video is not showing. Okay, sorry about that. It's okay, so now I can see. Okay. So, yeah. So as I was saying, in an example like the animal, different animals, they make noises. Every animal of those big ones, dog, cat, a bird, they make noises. So you can generalize and say animals make noise. However, different animals will make different noises. The implementation of that noise is different for each one, for each different animal out there. Okay, so that's what polymorphism is when it comes to coding. We have the same make noise. Animal, cat, make noise. Dog, make noise. Human, make noise. The name of our methods, of our action is the same. However, the implementation, the details of how that noise sounds like is different. So we have one single name, but different forms on each one of them. I'm going to give another example. Music instrument. Well, if I say, can you play the instrument? What would be your question? Every instrument can be played. However, to know if I can play the instrument, what is again, the natural question is, which instrument? Different instruments will be played in different ways. The play method is the same name for every single instrument, but the execution of how that instrument gets played is different. That's what polymorphism is. Poly, many different forms, but for one single action. You can think about that. One single method, okay? And that's what I'll be demonstrating today with this exercise. So that's polymorphism. The other thing was, okay, so let's get started with the exercise number 1. And again, the solution for every single one of those exercises is provided, and it's going to be open as soon as we're done with our meeting today, okay? But let's go one step at a time here with this exercise. Shapes demo. Shapes demo is the name of our application here. So I'm going to go to Visual Studio. I'm going to go to File, New, Projects. And here we have console app.NET Framework. I'm going to hit Next. And I'm going to have here our Shapes demo. Okay. I'm going to hit Create. We have our application. And now it tells us to do what? Let's see. Create an application named Shapes Demo. We did that. That creates several objects that descends from an abstract class called geometric figure. Okay, so we're gonna create an abstract class here. Again, another term, abstract. What comes to mind when you think about abstract? What is that? What, again, you don't need to be precise, but just give me an idea of what comes to mind when you hear the word abstract. Not fully defined thing. Okay, that's a good one. Not fully defined. Any other opinions there with regards to abstract? Okay, Kevin, not exactly the same as something it represents. Okay, got it. Mateo, like abstract art, yes, it's not, well, it's not what? If it's abstract, it's not, Mateo, cannot be instantiated. That's a very good one. And again, who can fill this up here? An abstract class, something that is abstract is not what? What would be the opposite of abstract? Aman, concrete. Yes, that's it. Concrete. So if I ask you this, have you worked before with a concrete class? What would you guys tell me? Yes or no? Have you ever worked with a concrete class? Yes, Kevin. Mateo, I believe it only can contain abstract methods and accessors. Okay, that's the belief of Mateo. We're gonna talk about that belief, Mateo, in a second. But again, the question is, have you ever worked with a concrete class before? Yes or no? Aman, yes. All of them have been concrete. That's correct, Mateo. Very good point there. So yes, we have worked in all of our classes so far that we have worked before this one here today. They were all concrete classes, because concrete classes you can instantiate. You can say new students, new photo, okay? New, whatever it is the class, okay? Now, with an abstract class, you cannot instantiate objects of that class. You can declare, but you cannot instantiate. You cannot say new geometric figure. You cannot say new, okay? You can declare, but you cannot instantiate, okay? We're gonna see more about that as we go along, but that's something that I would like you to keep in mind. Abstract classes you can declare, but not instantiate. Okay, so let's create this class, geometric figure. We're gonna do it the same way as we do with any regular class. I'm gonna go here to our shapes demo. I'm gonna right click the solution, sorry, the project, and then I'm gonna go to add, new item. I'm gonna select the class, and it is called, sorry, I just messed up here. Let me go back, copy this, and paste this, geometric figure. Okay, so far, just a regular simple class. However, we're gonna be making this class as an abstract class. So we're gonna use the keyword abstract. So I'm gonna put it here, abstract class. Okay. Now, again, Mateo, this will go towards your point there that you have mentioned earlier. In a concrete class, we only have concrete members. We only have methods that are implemented. We only have properties that are implemented, constructors that are implemented. We don't have abstract members in concrete classes. Concrete classes only has concrete members. However, abstract classes can have both concrete members and abstract members. Okay, slightly confusing. You may think that because it's an abstract class, it can only have abstract members, but no. Abstract class can have abstract members and concrete members as well. As we're going to see, geometric figure, we're going to have both of them. We're going to have concrete members and abstract members as well. Okay? Again, it's a good one for to have in a quiz, you know. Just going to repeat, concrete classes can only have concrete members. Abstract classes can have abstract members and concrete members. And I'm going to add to it. I'm going to add one more element there. When it comes to interfaces, interfaces is not exactly a class. Interfaces can only have abstract members. All members of an interface, they are all abstract. Interface is a little bit similar to abstract classes, but again, one of the first differences is that abstract classes can have concrete and abstract members. Interfaces can only have abstract members. Okay. Okay, so let's keep going here with our geometric figure. Let's see. Okay, so each geometric figures includes a height, width, and area. Provide get and set accessors for each field except area. Okay, so so the exercise here is not very clear in the sense that are those auto-implemented properties or fully implemented? Well, for the sake of demonstration, I'm gonna make them fully implemented. We're gonna have fields and we're gonna have properties, okay? It's not clear about that in the exercise, but I'm gonna go that direction. So width and height, they both have gets and sets, but area will only have a get because it is a read only. So let's define that. I'm going to start with the fields. I'm going to say private double width. And I'm going to say private double height. And also the area, private double area. Okay. Okay, great. So now let's create the properties so we can read and write from the fields. So I'm going to say public double width. We have a get and a set. The get, I'm going to return the width. Again, nothing different here. Actually, look at this. This get, this is not abstract. This is concrete, okay? Because we have the body of our get accessor and the body of our set as well. I'm going to say set width equals to value. We're going to double that for the height as well. I'm going to create a one for the height too. So I'm going to have height. Okay. And I'm going to have area, but area will only have the gets. Okay. So I'm going to say public double as well. Area. And we're going to have a get. And I'm going to say return area here. Okay. So 3 properties here created with 3 fields. And we are good so far. And actually, let me just copy Padlet link here, just in case anyone wants to ask a question over there as well. Just going to register there. I'm going to put it there. So next here in the exercise, let's see. So includes an abstract method called compute area that computes the area of the geometric figure. So let's think about this. Include an abstract method called compute area. If I ask you, do you know how to calculate the area of a geometric figure, a shape? Do you know how to calculate the area? What would you say? What would you ask me? Thunk, you need to know the shape. That's a good point. That's a good point. If you just say, calculate the area of the geometric figure, I'm going to say, which shape is that one? Because different shapes will have different formulas. We have the formula of a rectangle is not the same as a triangle, which is not the same as a circle or an ellipse. Okay, so different ones, different shapes will have different ways to calculate the area. That's why in the generic abstract class called geometric figure, we cannot implement the details of how to compute the area Because it depends on which shape is that one. So, however, I can tell you this. For all geometric figures, there's a way to calculate the area, but it depends on the geometric figure. So I can say, I can define in the abstract class geometric figure, I can define, hey, I want to create an abstract method called compute area. But I cannot define the implementation because I don't know which shape is that one. Okay, so here's what I can do. I can say here, public, let's say that is a void, public abstract void, there's no return type, compute area. Compute area will calculate the area of the shape. However, here in the geometric figure, this is an abstract method, which means it does not have a body. It does not have curly braces. It does not have anything inside curly braces because it's abstract. If I get rid of the word abstract, then it requires a body. But with abstract, we don't need a body. We can finish the line with a semicolon there. We don't need curly braces. We don't need the body. We are just saying, hey, this is really what this is saying. This is saying, if you are one of my children, then you have to implement compute area. If you want to inherit from me shape, geometric figure, you have to implement compute area in your class. If you want me to be your parent, let's put it this way, okay? So this is our abstract member, abstract method here. Let's keep moving forward. Then we have to create 3 additional classes: rectangle, square, and triangle. Okay. So let's just put them together. Rectangle. Let's not do the full implementation yet. Let's just put them together. Right click, go to add, new item. And then we have rectangle. Then we're going to have square. Right click there again, add new item, square. And then we have triangle. Right click, add. I can click directly on class here as well. And I'm going to call it triangle. So we have our 3 classes. Now, let's start with the first one. Rectangle is a geometric figure whose area is determined by multiplying the width by the height. Okay. So when you say something is something else, a cat is an animal. A dog is an animal. What you have there is a parent and child relationship. You can call it superclass, you can call it subclass, okay? But when you say is a, you are giving an example of inheritance there. A class, this is a, a student is a person. An instructor is a person. Again, we are talking about a relationship of inheritance there, okay? So how do I say that a rectangle is a geometric figure? How do I demonstrate that here inside the rectangle class? What should I do here? What should I add to make rectangle inherit from geometric figure? Anyone in the chat can help me out here? Okay, Kevin. Yeah, it's going to have, the rectangle is going to have height and width, but it's going to have height and width coming from the parent's geometric figure, okay? So I Aman, rectangle, column, geometric figure. That's it. So I'm going to say rectangle, column, geometric figure here. The same way as you have seen the inheritance. Remember photo, we had a framed photo and matted photo. They inherited from photo in our exercise last week. The same thing here. Just because it's an abstract class, it doesn't change how we inherit from another class, okay? The same way as you have seen before. Even to the point that any class can only inherit from one other class, whether it's an abstract class or a concrete class, it doesn't matter. One class can only inherit from one other class. However, there is the concept that one class can inherit from multiple interfaces, okay? One class can only inherit from one class, but one class can inherit from multiple interfaces. That's why I would highly recommend that you go through the content of week number 9 in details, including the extra parts, so you can get to know more about interfaces as well, because I won't be demonstrating that today because of lack of time, okay? Anyway, geometric figure here. Now we have a problem. Houston, we have a problem here. Rectangle. Rectangle does not implement inherited abstract member compute area. Here's what it's saying. Hey, remember I told you that if you want to inherit from geometric figure, you have to implement compute area. You have to code that. You cannot leave it unimplemented. You have to implement it. You cannot leave it undefined. So in our rectangle class, we have to say exactly, Mateo. We have to say public, that little keyword that you have used quite a lot when dealing with toString. Remember, who remembers that one? What is that keyword? When we are doing toString to ignore the ones from the parents, we use the keyword what? What is that keyword? Again, just see if anyone remembers that keyword. Mateo just put it there already. So that's override. Okay, so I'm going to go public override so that we can say, hey, ignore what is defined in the parent, even though the parent, in the parent, it's an abstract member, but I still have to use the override keyword, okay? Because I'm going to say, hey, ignore that. I'm taking care of that now. It's void. And we're going to do compute area. Okay, so I'm going to just get rid of this. Now we're gonna calculate it here. Calculate the area here, just multiplying the width by height. Okay, so let me ask you this. I'm gonna say area equals to width times height. Okay, or area equals to width times height. Which one would be correct here? Let's have a look at the geometric figure. Looking at the geometric figure, which one is correct? The area with capital A or with lowercase a? The first or second? Which one? Which one is correct? Area with capital A. Okay, that's Kevin's. Anyone with other, I'd say, opinions here? Aman with lowercase a. Why lowercase a, Aman? Any reasoning for that? The return is area with lowercase, okay? Okay, so let's look at this. If we try to do with uppercase, look what we get. Area, if you look at geometric figure, area does not have what? What area does not have? It does not have a set. which means that it is read only. Okay, it is capital, yes, but the thing, Kevin, is that it's read only because it does not have a set. So we cannot assign a value to it like this. Okay, the value must be coming from the lowercase area. Okay, so again, unless we had a set, otherwise you cannot set it. Now, what if I try this? I'm gonna get rid of this guy and do the other one. We have a problem here. Okay, look at the arrow. Let's look at the geometric figure. How do I fix this part here? Let's look at the definition of area. What should I do with this definition to make sure that I'm able to access area right here? What do I need to change here? What should I change in this area field definition? Aman, to make it protected. Okay, so remember, we have private, protected, and public, okay? Private can only be accessible inside the class. Mateo, in this case here, Mateo, the abstract, the fact that this class is abstract, it doesn't impact what I'm about to say, okay? It's really about the visibility of that property, of that field, okay? So remember, private only inside the class, protected inside the class and inside the children, public inside the class, inside the children, and outside the class, okay? So, Kevin, if we put it public, yes, it would work. However, we usually try to keep the data as close as possible. So do we need to go all the way to public, or would protected be enough? So instead of private being protected, we're protected inside the class and inside the children as well. And guess what? Rectangle is a child of geometric figure. So if I change area from private to protected, this should work now. So I didn't have really to go all the way to public, Kevin. I could, but I should not, because we only open up whatever is necessary. You don't need to open up completely, okay? Again, just one of the best practices of object-oriented programming, which is you keep the data, the information as close as possible, as private as possible, okay? So we try to avoid going all the way to public. Public, we have properties, we have methods, but data itself, like area is a piece of data, we should keep it closer, if not private, but at the very least protected so the children can see it, okay? Don't know if this makes sense, Kevin, but you tell me if you have any follow-up, okay? Awesome, so I'm gonna keep this line here. Okay, so now here's the thing. Could we do with lowercase w and lowercase h? Well, we could, but we'd have to change from private to protected, okay? That would be the only way to make it, to be able to say lowercase width here, okay? But I don't have to because I already have properties, so I can use directly my properties here, okay? Okie dokie. Again, keep in mind that you can ask questions on Padlet, you can ask questions in the chat as well. Let's keep moving forward. Rectangle, we did the calculation just now. Let's have a look at our square. Square is a rectangle in which the width and height are the same. So I'm going to expand this exercise a little bit beyond the initial scope of the exercise. I'm going to talk a little bit about constructors and how constructors work in the context of inheritance, okay? So look at this geometric figure. Even though geometric figure is an abstract class, but it has a default constructor as well. We cannot create we cannot say new geometric figure because it's abstract, but it does have the definition of a default constructor, okay? A constructor that has no parameters. However, sorry. Because we have a default constructor, the children of this class, it will also have default constructors, okay? However, if I change and I go here to geometric figure and I create a new constructor for this class, and I'm going to create a constructor that defines the width and the height. Look at this. I'm going to go down here. I'm going to say public geometric figure. And I'm going to send two parameters here. I'm going to say double width and double height. Okay. And I'm going to set to the corresponding properties here. I'm going to say width equals to width and height equals to height. Okay. So here we have a new constructor. Now, this constructor is not the default constructor because the default constructor has no parameters, no arguments. But look, we have an error here. It says there is no argument given to the there is no argument given that corresponds to the required formal parameter width of the geometric figure constructor here. So look, geometric figure has a constructor here, but this constructor is not the default one. Because of that, we need to define also our own constructor inside any classes that may inherit from geometric figure. Because now, once we create our own constructor, guess what happens to the default one? The default one remains or goes away? Tell me that there in the chat. Remains 1, goes away 2. 1 or 2. Does it stay or does it go? The default one, the default constructor, once you create your own, does it stay or does it go? It goes away. Okay, yes, it goes away. Once you define your own constructor, the default constructor that comes by default, no longer exists. Because of that, the children of this class needs to implement the constructor as well. Okay, and we need to do something like this. Look, public rectangle, and I'm going to capture the width and height as well. So I'm going to say, double width and double height. Okay. And we have to put the body. Now, you may be tempted to do something like this. Width equals to width and height equals to height. But the thing is that we still have a problem, and this is already being done in the geometric figure. It's already here. So in a way, we would be duplicating code if we do this again. But there's a simpler way. There's a way that we can call the parent constructor in our child constructor. We can say something like this, look, column, who remembers the keywords that makes a reference to the parent? What is the keyword that makes a reference to the parent? Anyone there in the chats? The keywords that makes a reference to the parent class. This makes a reference to its own class, to its own objects, Mateo. Okay, I'm trying to go to the parents. We have seen that keywords last week. Aman, Mateo, base. Yes, it's base. So I'm going to say base, open brackets. Now, the constructor of the parent requires two parameters here. So I'm going to send the width and the height to the base constructor as well. So I'm going to say width, which is this one here, comma, height. So when we call the constructor of the child, first the constructor of the parent runs. Okay, so we call the constructor of the parent with whatever parameters we are trying to send over, and then it runs. Then the children will run. Now, this becomes useless. I don't need this part anymore because this has already been set in the parent there. Okay, so whenever you create a child, the parent constructor is the one that runs first, then the child constructor. Now, this going cascades, okay? So the parent tries to run, but then the constructor of the parent runs first, of the parent of the parent of the parent, and goes on all the way until it reaches what? What is the class that is on the top of the hierarchy in C#? All the way to the top. Again, I'll keep asking this question. What is the class that is all the way up to the top of the pyramid? Yes, Mateo, objects. So again, when you call the constructor of a class, first the parent's class constructor is the one that runs first before the children, okay? So here, again, I'm calling the constructor of the parents, okay? Passing as arguments the width and the height again. And I can leave the constructor here without any lines inside the body. It has a body, but the body is empty in this case. Okay? So this is how you call the... Now, this is not necessary when you have a default constructor, because you don't need to explicitly call the constructor of the parents from the child. They call them automatically because all of them will have default constructors. Only when you have custom constructors is when you need to call them individually, specifically, like we are doing here. Okay. Okay, so let's see here what else we have in the exercise. So we are still trying to get the square going here. So square is a rectangle. Okay, so let's do this one here. Square is a rectangle, so let's go to the square. Let's tell it that it inherits from rectangle, so I'm going to say rectangle. Okay, so now we have geometric figure, rectangle inherits from geometric figure, square inherits from rectangle. So we have three levels now: geometric figure, rectangle, and square. Okay, now it's complaining about, again, about the constructor. The constructor, we don't have a constructor here. So we're going to create one. We'll look here for the square. So for the square, look at the definition. Provide a constructor that accepts both height and width, which, by the way, it doesn't sound very logical. You're going to see that in a second. Forcing them to be equal if they are not. So there is a simple way to do this. We're just going to say public square. We're going to have two arguments here, height and width. I'm going to say double width and double height. Now it says force them to be equal if they are not. It doesn't matter if they are equal or if they are not equal. What I'm going to do, because it's a square, the height and width are the same. So I'm going to completely ignore this height here, and I'm going to send to the parents width twice. I'm going to say this base. I'm going to call the base. The base, who's the base here? For the square, who's the base of the square? Rectangle. So the base of square is not yet geometric figure, it's rectangle, okay? So I'm going to say, hey base, send the width twice here, because I want to force this to be a square. I don't care really about the heights. If they are different, set the width on both. If they are the same, then width is the same as height. Okay, so either way, we are good to go with width and width here. This will guarantee that this will actually be a square with the same height and width. Again, base is still waiting for a width and a height. However, they are the same in the case of a square. Okay, they're the same dimensions. So this is the first constructor, which, by the way, I find it to be a bit of a useless constructor because, again, it does make sense for a square to have both parameters. You should have only one, really. Now, provide a second constructor that accepts just one dimension and use it for both height and width. Okay, so let's work on a second constructor here. So I'm going to say public square. And instead of width and height, I'm going to just say side. I'm going to say double side. Kevin, could you go over the width again, like how it shows width and height when you... Yes. Okay, so look, Kevin, base, if we are in the square, the base of the square is a rectangle, okay? So when I move the mouse over base, it shows that we are calling the constructor of the rectangle, which has two parameters, the width and the height. However, in a situation that we have a square, both width and height, the width and height, they are the same. They are the same. They cannot be different, otherwise they are not a square, okay? So I'm forcing them right now with this constructor to just ignore the height and just double the width there to represent the width of the rectangle and the height of the rectangle. Okay, so because I need to send those values to the rectangle, because rectangle is the one that is calculating the area. I don't need to recalculate the area for the square, because the square is also width times height. It just happens that they are the same values. So compute area, I'm not going to redefine compute area in the square because the formula is the same as a rectangle. So again, I'm just doubling that because the rectangle expects two parameters, height and width. However, I want to force the height and width to be the same. So I'm just going to double the width here. It's forcing that already. Again, don't know if it makes a little bit of sense, Kevin, but I'll be honest as well. I find, as I said, this constructor here a little bit useless because, again, we just need one parameter here. The second constructor now, this is a good one. So the second within the base kind of overrides the height. Yeah, so this one here, the second one. Oh, so this, yes, it's not about overriding really, Kevin. It's really just about I'm sending the value of the width as the height as well for the parents, just to guarantee that this will really be a square and not a rectangle. again, to be honest, I find this a very useless constructor, because in the case of a square, it only makes sense to ask for one dimension, for one size. And for that one, we can call base again, and you can say side, comma, side. This makes more sense. This one here really does not, because height is useless. Useless in the case of a square. We only need one size, and this becomes the height and width. Okay, this makes sense. This constructor here. Okay, that's fine. That's fine as well. But here's the thing, Kevin. If you do width to the power of 2, you are redefining how to calculate the area of the square. And you don't have to, because you can leave the square calculation, sorry, the area calculation in the rectangle. You don't need to double that in the square, because the calculation is the same. Okay? Otherwise, you're going to be doubling the codes. Okay? Okay, so we have square, we have the two constructors, great. What else we have? Okay, look, that's exactly what it says at the end here, Kevin. The square class uses the rectangle's compute area methods. So it's using the same thing there, okay? And then we have a last one, which is a triangle, but let's do the triangle in 5 minutes. Let's have a quick break. 5 minutes, we do the triangle, we wrap things up here, and we will be doing 2 other exercises, but not like this. It's one quiz and one puzzle, okay? Again, 5 minutes, be back, and we wrap this up. Okay. So let's carry on here. To wrap things up with this exercise, actually, there's still quite a few steps here. So the next one, we're gonna have a triangle. Now, a triangle is a class that comes from geometric figure. So I'm gonna, actually, the class is already created, so I just need to open it up and say it comes from geometric figure. And now, as always, we have to implement the compute area. So I'm gonna, for the triangle, the area is determined by multiplying the width by the height and dividing by 2. Okay, so getting half of it. So I'm gonna say public overrides void compute area. Then I'm gonna say area equals to width times height divided by 2. Okay. So we did the compute area, but we also have to do the constructor. Okay. Because again, we no longer have a default constructor, so we have to define it. So I'm gonna say public triangle. We're gonna send the width and height and we have the option, as we did before, not to have the option. We have to call the constructor of the parents. We don't have an option here. We have to call. So whatever we do here, it's in addition to, but we must call the constructor of the parent. So I'm going to say base. I'm going to send the width and the height as well. Okay. So we have the constructor here. All good. Triangle here. Great. Just have a look here. Okay, so there's a question here. How do you get sides? So side, I'm going to assume that you are talking about this one here. Sides, I get when I call the constructor. When I create a new square, and I'm going to do that in a second. And when I create a new square, I have the option to set the width and the height, or I have the option just to set the side. Okay, I will set this manually. I'm going to say, hey, I need a new square. And my new square will have the side as of 4 centimeters or 4 inches. Okay, so I need to say that when I'm creating the square. I'm going to do that in a second. Okay, so now look, in the shapes demo class, actually you can read this in the programs class, here, in the program class, or you can rename this to be called shapes demo if you want. But I can say after each object is created, pass it. Okay, so let's stop right here. So let's create 3 objects, 1 rectangle, 1 triangle, and 1 square. Okay, let's create them. So I'm going to say rectangle rec01 equals to new rectangle. And I'm going to call it, I'm going to say that this is a 4x3 rectangle, 4x3. Okay. Then I'm going to create a square as well. So this square, I'm going to call it SQ01. And this is a new square. Now, here is the side. I can define the side here. I have 2 options. I can define the width or height. See, it has actually 2 constructors. Sorry. See, it has one constructor with one parameter, just a site, another one with sites with width and height. I'm going to use the first one. I'm going to say that I just want to put the sides. So I'm going to say I need a square with 4. I don't have the unit defined here, so I can say 4 centimeters, 4 inches. Okay. And I also have a triangle. TR01 equals to new triangle. And we have a height and width here. I'm going to say this is a triangle which is, I don't know, 6 by 7. 6 by 5, let's say. Okay. Okay, great. So I have created 3 objects here. Now, look at what it says in the question. So create each object after each one is created, pass it to a method that accepts a geometric figure as an argument. Let me stop here and let's do this method there, okay? So the method that I'm going to create here in the program, I'm going to call it, this is a static because I'm calling it inside the main. The idea of this method is to display the properties of the shape. Okay, so I'm going to say there's no return type. I'm going to say void. And I'm going to call it display info. And look what it says. It says that the argument is a geometric figure. So I'm going to send this. I'm going to say that the argument is a geometric figure called figure. And now we need to implement this. Now, as I said before, abstract classes, you can declare arguments from it. You can declare variables of that type, but you cannot create. You can declare, but not create. But then you say, what is the point of declaring if I'm not creating it? Well, here, for example, you can define that display info is expecting a geometric figure. However, we can send, it can be a rectangle, it can be a square, it can be a triangle, it can be any one of those, because we can pass through a child of this class. So all of those, they are children of this class. They are children of geometric figure. So we can send to this method any one of those. Before we send them, let's implement it. The idea is to display the information about that shape. How do we do that? How do we display? Well, we can do something like this. We can say console.write, and I'm going to say, let's say figure is the name of the argument, figure dot width times figure dot height, and then I can say that the area is equals to figure dot area. Okay, great. So I'm just printing this line with the details about the figure, the width, the height, and the area. Now, look at this. I don't even know which figure is that. It can be a rectangle, a square, triangle, but I know that all 3 of them, they have a width, they have a height, and they have an area as well. Okay? Now, let's call it, let's say display info. Right after we create, we say display info display info with rec01 as the argument. Display info and square 01 as the argument here. And the last one as well, display info and tr01 as the argument. Okay. How about we give this a try and we see how how this gets printed out. Okay, let's go for a Control F5 and see how this runs. Okay, look at this. Let me just zoom. Okay, so we have a little issue here. The dimensions are being printed out correctly. You see, 4 by 3, and then square 4 by 4, and then triangle we have 6 by 5, but the area is coming up as 0, which means that we forgot about something. We missed something there. Okay. The question is, what is it that we're missing? Let's go back here to the geometric figure. We have compute area. In the rectangle, we have compute area as well. In the square, we don't have because it's inheriting from rectangle. In the triangle, we have compute area. What is it that we are missing? By looking at these, what do you think we are missing? Come on, any thoughts there on what we are missing here? We have compute area, but the question is, are we using compute area? Kevin, a return in compute area. We could put a return here, but is that really a problem? The problem, hear me out. The problem is that we have the methods, but we are not using it. Where are we calling this method? We have never called it. We have the method defined, but we never called the method. So how can it run? How can it calculate the area if we never called it? Okay, we defined it, but we never called it. Let me tell you one thing. Even though this method here, calculate compute area, is abstract in the geometric figure, but we can still call it, even though it's abstract. And guess what? Where do you think we should call compute area? Where do you think we should call that? Remember the photo example that we saw last week, that we called the method to calculate the price of the photo? Okay. We have to think of what is the area related to? What is it that the area depends on? The area depends on what? On which information? Aman? Yeah, depends on the height and width. So, once again, where should I call? Sorry. This trackpad is a little bit too fast. Okay, here it is. Where should I call compute area? Because it depends on height and width. We should call it inside where I set the height and where I set the width, because the area is related to both of them. So I can say, whenever you set the value of the width, compute the area. Whenever you set the value of the height, compute the area as well. Compute the area of both of them. Okay. Let's give it another try. Let's see here. Control F5. And now look what we have. 4 times 3, 12. 4 times 4, 16. 6 times 5, 30. Gonna get half of that, 15. Okay. So now, because we change the width and we change the height, we change them via, when we call the constructor, we change them. Now we get the area calculated properly, okay, during the set of the height or in the set of the width. We get there, we calculate the area there. A bit mind bending, a bit strange. Kevin.
So it would be easier to
Yes.
just chat than type. But when you put the compute area into set in both the width and the height place, does that just mean that when it gets triggered in the width, it fills in the width, and when it's in the set, it gets triggered and makes the height? And then once it has both those values, it then carries out the calculation for area. Is that the way that works?
Okay, good question. So actually, here's the thing. One has to happen before the other one. See, we don't set the height and width at the exact same moments. If you look at the, for instance, here, we first set the width. So
Right.
when we do this, compute will calculate. However, at that point, when we set the width here, what is the value of the height the first time that we set the width?
0.
0. So at that point, the area becomes 0. However, right after you set the width, you also set the height. So at this point here, width will be already there.
Okay.
Height is coming in. Now we have a proper, the proper math to get them.
Okay.
You got it?
Yeah, that makes sense.
Now, again, I could revert this and we still get the same result. So because we have duplicated in a way, I don't like duplicated because we are not really duplicated, but we did the same thing on both of them. Doesn't matter which one you change, because later you may want to change the width and maybe not the height. So again, you need to trigger the compute area once again if you change any one of them individually,
Okay, that makes sense.
Okay, awesome. Awesome. Okay, so, and here's an example. Actually, let me see. Let me just double check here. Yeah, because it's public. So look at this. I can say that rec1 dot width is now a new width. Let's say it's no longer 4, it's 5 now. And after that, I can display the information again, and you're gonna have this updated here. Look, let's go Control F5. And look, this first 2 lines, it used to be 4x3, we have 12. Now it's 5x3, we have 15. Because we changed the width, and this change here triggered the compute area once again. Okay. Quick note here. What if we want to show the name of the class as well in the console? What if we want to say that, oh, okay, this is a triangle, this is a square, this is a rectangle? What is the method that we can use that comes all the way from objects to show the name of the class? Anyone remembers that we saw that last time? It's a little method that we can call to get the name of the class. Okay, who remembers that? It's a get something. It's a method called get something, and it comes from the object. Okay, we can say figure dot get type. Remember, we have the look at get type last time, and I can say get type just like that. Okay, I'm showing the type. Let's have a look here what we see this time, and there we go. We have the namespace dot the type. rectangle, rectangle, square, triangle. So look, even though we are referring to it as a geometric figure, but what is coming through is a rectangle, a square, a triangle, because again, geometric figure is abstract, but it can receive concrete objects, which we have here, rectangle, square, and triangle. Okay. Okay, last thing here that I want to demonstrate, and this is something that came from a student from another section. Someone asked for me to explain how to use the methods substring from string, okay? Because this is one of the things that needs to be done for assignment 3. Actually doesn't need to, it's optional, but it's there. So some people wanted to get more details about that. So I'm going to show you with this example here. Let's say that we don't want to show the shapes demo dots string. We only want to show this part here, the name of the class. How can you get rid of this part? By using the substring method. How can you do that? Well, let's have a look at this. Actually, you know what? Let me run it again, because we need to get some information from this printout. Now, what I should do, what I have to do is get type is not a string, okay? It's a type, but by default, it brings whatever toString has to offer. For us to get the string from get type, we need to say toString here. Now, toString is a true string. It's a correct string. So because it's a string, I can get the substring of that string. I can say dot substring, and substring has 2 or 1 argument. If you just put 1 argument, it is the start index, where you should start to bring the substring back. So if I want to start right here, right in the R, I need to say the index will be 0, 1, 2, 3, 4, 5, 6. Whoops. Sorry. Okay, I know the index there. It's going to be 11. Okay, so I'm going to say 11. And with that, we're going to jump from the start, which is index 0. We're going to start in the 11, and we're going to get from 11 all the way to the end. So I can say Ctrl F5, and here we have all the way to the end. So starts in 11, goes all the way to the end. So now we just have the name of the class. Okay. Now, substring, it also can have 2 arguments. The second one is the length of, I want from that point 4 characters, 5 characters. Let's say, for the sake of example here, I want to have only the next 5 characters. So I can try to run this again. And now I can just have, look, just the first 5 characters starting in position 11. Okay. Look at this, look at this. So this is how you can use the substring. Instead of, the idea in the assignment is that instead of bringing the entire message of the tweet, you can cut it down and make it shorter. That's it, but it's optional. You don't have to. It was just a suggestion. Okay. Okie dokie. Any questions? Any comments? Any 10 o'clock questions? By the way, I don't know if this made sense already for the person that wrote this question. I hope so. If you did not find your solution, you can follow up with another question. Okay, please. Okay, so I think that we are done here. I'm gonna jump to take a quick attendance. Then we're gonna do a few quick and simple exercises just to reinforce a little bit more the abstract concepts that we have seen today about abstract classes. Okay, so I'm just gonna get the attendance here. If you hear your name, just say hi in the chat. We are section 003. Okay, there we go. So Alex, I saw you before. Alex Zyong and Amin. Amin is there. Alex Zyong. Okay, Aman, Bagyesh, and Isan. Isan and Aman. Okay. Kelly, you're there. Janeth, I think I saw you there as well. But just confirm that. Yep. Okay. John Tran, Johnny, and Joshua. Joshua is there. John Tran. Okay. Johnny, I don't think you're there. Okay. Kevin, you're there. Cody, I think I saw you, Cody, as well. Kyung Byung, Lester, and Luis. Mateo, you're there. Fayaz, Muez, and Rafsan. Fayaz, Muez, and Rafsan. Ryan, Roshan, and Seong Kun. Ryan, Roshan, and Seong Kun. Okay, Sina, Stas, and Sultan. Anyone? No. Sumi, Sayeda, and Tank. Tank, you're there. Sayeda, okay. Okay. Tian Yu, Tirth, and Vikas. Okay. Walid, Yahya, and Zobair. Yahya. Zobair. Okay. Okay. Okie doke. So I'm going to show you a little exercise. It's a simple one. It's a very simple one. It's more about reinforcing some of the things that you have picked up today about abstract classes. This is a type of exercise called Parsons problems. Okay. And it works like a little puzzle with the code. Okay. You're not going to be coding, but you're going to be fixing a piece of code there. So the first one is this one, and I'm going to use it as demonstration. It's just a simple class. And I'm going to copy that to the chat and to Padlet as well. So open that link, and I'm going to solve this for you so you can have a look at how this works. So here you have a class employee with a constructor, and you have to put the elements together correctly in the right-hand side by dragging. You click, you press the mouse, and you drag over, and you have to organize it. There might be some lines here that are here to complicate your life, so you have to understand which ones you should use, but the idea is create a class employee with a constructor inside of it. So let's put the elements here together. Class first, then I'm going to open brackets here. I can click get feedback to see some comments there of my progress. I didn't get too far yet. So I'm going to put the constructor. Constructor will be this one, the first one, or the second one. Employee constructor or just employee? Which one is the correct constructor? 1 or 2? Just employee. Yeah. So I'm going to put it here with a little bit of indentation. So let's put indentation there as well. Then I'm going to open brackets here, curly braces. I'm going to put this message inside of the constructor. I'm going to close the constructor. and I'm gonna close the class as well. If I click get feedback, now it's all green, and this is correct. So a very simple one, just to play around a little bit with the elements of classes. And I'm gonna provide in one now that is about abstract classes. Okay, so I'm gonna give you a minute to get this one done. Here's the next one. I'm gonna post that in Padlet and in the chat as well. Here's the second one. And I'm gonna give you a minute just to try to put this together. It's an abstract class with an abstract method inside of it as well, okay? So let's see here, 1 minute, and give it a try. Once you are done, you can post on Padlet the print screen to prove that you are done. Let's see here if anyone is done with it already. Okay, let's have a quick look here. So this is an abstract class. How do we define an abstract class? Is that class abstract or abstract class? 1 or 2? Abstract class. Okay, so I'm gonna go abstract class. I need to open brackets. I need to close brackets. I like to put them like this sometimes. And I need to have a public abstract method inside of it. So when I get feedback, I'm all good. The next one is similar, but slightly more complex, just a tiny bit. Here's the next one. Again, it's an abstract class once again, but it has a few modifications there. In Padlet as well, I'm gonna put it there. Let's give it another minute here, so you can give it a quick try and see how it goes. We have the animal abstract class here. Again, don't forget to go through the content of week number 9, okay, including interfaces. Okay, let's have a look here. So for this one here, we have an abstract class, animal. We're gonna open brackets, close it at the end, and then which one of those is the correct way to define an abstract class? 1 or 2? Number 2, because number 1 here, we have a body, okay? Number 2 means that, you know, it ends in a semicolon, which is the right combination to define an abstract methods. Okay, so I'm gonna put it here, get feedback, and this is good. I would like to bring more of this type, but a little bit more complicated, you know, a little bit more complex. But you know, I don't know how you guys feel about this kind of exercise of activity, but yeah, I would appreciate if you give me some feedback. I would like to run before we. Awesome, Kevin. That's good. It's no, the idea is to have an exercise with less thinking, and more about focusing on the concepts that have been discussed here. Yes, yeah, it does. Awesome, Alex. Thank you for that. Thank you for the feedback, everyone. Okay, so before we go, let's just do one quick quiz. It's a simple one, 4 questions. I'm gonna give you 3 minutes, and then I will review them, and we are done for the night. Okay, so let me just do this one here. The link, it's all about abstract classes, and it will work and help you to reinforce what we have done, what we have gone through today. Okay, so here is the little quiz. 4 questions only, and I'll give you 3 minutes here to get through it. Give it a try. 4 questions, and I'll go through the answers with you. I think that we can give it a try. Those were relatively simple questions, except the last one. It's a little bit trickier. Let's give it a try here. Let's jump to that one. So let's go one by one. Okay, so here we have, when you create an abstract class, oops, okay, let me do it anonymously, because otherwise it's gonna come pre-answered already, because I have done this before. Okay. Okay, so we have seen this before. When you create an abstract class, you can inherit from it. We saw that. You can inherit from geometric figure. You can create rectangle, squares, triangles. You can create concrete objects. No, you cannot. You can declare, but you cannot create. Okay, so we have letter A here. Next one. Okay, so when you create an abstract method in an abstract class, you provide what? B, let's see. The keyword abstract. Do you provide curly braces? Do you provide method statements? No, you don't have body. You don't have body for an abstract method. You only have the method's signature, including the keyword abstract. Okay, so very good, Mateo and Aman as well. So yes, the keyword abstract is the only thing that you're gonna keep there. Well, a method has no method statements. Any class that derives from this class, from a class that contains one, must override it by providing a body. That's what we saw when we had to implement calculate area. Calculate area, we needed to override it. So an abstract method has no method statements. Okay, let us see. Thank you, Mateo. Concrete is the opposite of abstract. Okay, so we have an abstract method without statements. And the last one is the one a little bit more, I would say, can be a little bit challenging, but let's see here. C, inheritance is, which means a child inherits all members from its ancestors, all the way up to the object, okay? Again, I don't really expect you to know that, but this property is called transitive. The class at the bottom, it inherits everything from all of its ancestors, not only from the immediate one, but from the one, the parent of that, the parent of that, the parent of that, up to objects. Okay, so this is called transitive. Okay, that's it, everyone. Thank you for sticking around this long. Let me know if you have any questions. Let me know if you have any comments. I'm one email away. I am supposed to answer some of your emails. Maybe someone here in this group is waiting for an answer from me from email from today. So I'll be answering them. I'll be answering you tomorrow morning. Okay. Have a good rest of your evening. Have a good rest of the week. Have a good weekend. Tomorrow morning I'll be around. Thank you, Alex. Thanks so much. I'll be around tomorrow morning for the office hours from 10 a.m. to 12 p.m. If that time is not good for you, you can always reach out to me. You can always talk another time. But again, I'm always one simple email away from helping you out, helping anybody out. Okay. Have a good night, everyone. Thank you so much. Thank you. Thank you. Bye now. See you next week. Thang as well. Thank you, Cody. Thank you, Jelly. Thank you so much. Thank you. Thank you for being here. Thank you for, again, being part of this. No. Thank you, Yahya. I always have to look twice. Yahya. Awesome. Bye now, everyone. Bye-bye.